And welcome to Project FAIL. This project is a radio interface that I've been putting together, and this is just a quick video to demonstrate read the data sheets. Don't just look at the pictures. So just a quick look. Microphone headset socket is there. PTT switch, PTT extension switch. The radio interface is here. This little bit here is a single transistor microphone preamp, and these two are opto couplers because the radio is controlled under a system called CAT and it's RS-232. So we have an RS-232 cable coming in to a connector here, coming up here, and here we have 5 volts, 0 volts, transmit and receive, an opto-coupler going in that direction for transmitting into the radio, an opto-coupler coming this way for transmitting back to the computer, because I wanted to isolate the computer from the radio in case there's any RF flying around on the grounds. So what were the problems with not reading the datasheet? Well, I have a transistor to turn the LED on when the input goes high, which of course makes the output FET or collector on here go low. So I have a transistor inverter, so it goes high. So a high on here produces a high on there. Right, we'll just jump forward a bit. What I've done here, I've put a scope on the transmit going in that direction, the scope on the receive coming back, and even though they're different colors, it's just the output from this optocoupler being fed back to the input of that one. So what comes in here should come out there. As you can see here, there's the data going out and the data coming back. Now it doesn't look very pretty, but if I expand it out, you can see that there is a slight delay, but the data is the same. Now this is only going out at 1200 baud. Now if I go up to 9600, you'll see a mark. This you see a difference. Now we expand it out, and now you can see it doesn't resemble it at all. And if I go up to the speed that I want to run it at, it's falling over. Quite a foul. This is the opto-coupler, or a MOSFET relay, so not really an opto-coupler, but it's what I had and I thought I would use it. But I was more concerned with looking at this. Okay, I've got an LED to turn on and I have got 2 MOSFETs that I can use as the switch the other side, isolated. Ticking the box, 2,500 volts isolation, everything I need. And what I failed to read was the operating time, 0.3 milliseconds. Fantastic for a relay, rubbish for a opto-coupler. And if you come down to the electrical characteristics, and if I'd read the bottom, the turn-on time, 0.3 typical, maximum a millisecond. Turn-off time, 0.1, maximum a millisecond. Yeah, very good. As fast as a relay. No good for what I wanted. So this was just a quick video just to show. Don't pull things out of your component boxes thinking, oh, I can use that, it does what I want, and only glancing at that bit of your only glancing at that bit of the data sheet, because you're heading for a fail. And now I'm going to go around my parts bin and try and find something else. Thanks for watching. If you like the video, click subscribe, hit the bell for notifications, and I'll catch you on another one. Hopefully the other one will work. Well, I didn't record it, but I took this chip off a isolator board, and I'm going to stick it upside down on my board, hardwire to it, and hopefully fix my problem. Just a quick one. This is the chip that I pulled out of the medical board to replace the Opto relay. Luckily, the chip I had was this one, the ADUM2401, which gave me 3 isolation devices in one direction and 1 in the return. So basically what I've done is I've used 1 to go this direction, and then I just paralleled these up to drive them in that direction so that they're all being driven, and just used one of the outputs. So that's the chip I used, and as you can see, 900 megabits a second, should have no problems. It will do level voltage transitions, but that's not a problem. It's on 5 volts both sides. Can take up to 5,000 volts. That's the chip I've replaced the Opto relay with. I'm zoomed in, so the focus doesn't seem to be very good. And what I'm going to do, I'm going to pour just off the word super glue. Well, here we can see the input on the top and the output after being looped back through, and we'll change the characters and just show that it is actually a reasonable output signal now. And then we'll go up in baud rate up to, I think this was 3800 something, and then the next shot will show the baud rate as the fastest the PC will do. And here we go. It looks, the output looks better than the input. So I think that's a pass.